of the matrix. So all the diagonal elements of skew symmetric matrix are 0. Now the next one is, next question is, let A be a square matrix. Let A be a square matrix, then A plus A transpose is symmetric. A minus A transpose is a skew symmetric matrix, and A into A transpose and A into A transpose are symmetric matrices. A be a square matrix, and we have to prove this. Take first part. Let P is equals to A plus A transpose. Take a transpose. We know the property of transpose. A plus B transpose is equal to A transpose plus B transpose. Use this property here. A transpose plus A transpose transpose. We know A transpose again transpose is equal to A. So it is A transpose plus A. Or we can write it as A plus A transpose. So P transpose is equal to P. Therefore P is a symmetric matrix. And what is P? A plus A transpose. Therefore A plus A transpose is a symmetric matrix. Now next is second part. A minus A transpose is skew symmetric. Let Q is equals to A minus A transpose. Take transpose. Q transpose is A minus A transpose transpose. Again use the same identity. A transpose minus A transpose transpose. A transpose transpose, that is equal to A. Taking negative sign common, A minus A transpose. Q transpose is equal to minus Q. That is Q is skew symmetric matrix. And what is Q? A minus A transpose. Therefore A minus A transpose is a skew symmetric matrix. Now third part. A into A transpose transpose. We know the property of the transpose, that is A B transpose is equal to B transpose A transpose. Take this, use this property here. B transpose, what is B here? A transpose. So A transpose transpose into A transpose. A transpose transpose, that is equal to A into A transpose. A transpose, it will be P. P transpose is equal to P. Therefore it is a symmetric matrix. A transpose A. Again use this property. A transpose transpose. A transpose transpose is equal to A. Let it be Q. Q transpose is equal to Q. That is, it is a symmetric matrix. Now the next one is question number 3. Write on the statement. Prove that upon transpose, that is K into A transpose. K is any scalar constant value, then it is equal to K A transpose. So half transpose, it will remain half as it is A plus A transpose transpose. Now apply the other property A plus B transpose, that is equal to A transpose plus B transpose. Now A transpose transpose, that is equal to A, so half of A transpose plus A. We can write it as half of A plus A transpose, that is a P matrix. So P transpose is equal to P, therefore P is a symmetric matrix. That is equal to P, P transpose is equal to P, therefore P is a symmetric matrix. Now let us start with Q. A transpose into A transpose is A. Now take negative sign common, then it becomes minus Q. Q transpose is equal to minus Q, therefore Q is a skew symmetric matrix. P is symmetric, Q is skew symmetric, therefore any square matrix can be expressed as sum of symmetric and skew symmetric matrices. Now let us start with the next question. Next question is question number 4. If A and B are symmetric matrices, then show that AB is symmetric if and only if AB is equal to BA, that is A and B commute. A and B both are symmetric matrices. We have to prove that AB is symmetric if and only if AB is equal to BA. Now since A is symmetric matrix, therefore A transpose is equal to A. B is also symmetric matrix, so B transpose is equal to B. Now we have to prove that AB is symmetric matrix. Then what we have to show? We have to prove that Now the next one is question number 6. Write up the statement. Show that all positive integral powers of a symmetric matrix are symmetric. Let A be a symmetric matrix. Let A be symmetric matrix. All integral power of this matrix will be symmetric. हमें ये प्रूफ करना है. A into A so on up to n times. We can write it as A transpose A into A n times transpose. That is A transpose so on up to n times. Since A is symmetric matrix, so A transpose is equal to A. Or we can write it as A transpose n. A is symmetric, so A transpose is A power n. So all integral powers of this matrix will be symmetric matrix. An transpose is equal to An. Therefore, it is a symmetric matrix. Now the next one is question number 7. Write the statement. Show that positive odd integral powers of a skew symmetric matrix are skew symmetric and positive even integral powers of a skew symmetric matrix are symmetric. इसके लिए हमें यहाँ तक तो इस क्वेश्चन को सॉल्व करना है. A ट्रांसपोज n पावर्स कोई भी इंटीग्रल पावर. यहाँ पे ये क्या है? स्क्यू सिमेट्रिक मैट्रिक्स. Then A transpose is equal to minus A. Now we know that A n transpose is equal to A transpose n. Since A is skew symmetric, so A transpose equal to minus A. If n is odd, minus 1 and An. If n is even, so minus 1 square, minus 1 power 4, 6, so on. Any even powers of negative 1 is positive, so it becomes An. So An transpose is skew symmetric if A is skew symmetric, n is odd, and if n is even, for even integral powers, this matrix will be symmetric. Now next one is question number 8. matrices. A and B are symmetric matrices. Therefore, A transpose is equal to A and B transpose is equal to B. Now, first part में we have to prove A plus B is symmetric. That is what we want to prove. A plus B transpose is equal to A plus B. Apply the condition of transpose property. A transpose plus B transpose. Since A and B both are symmetric matrices, therefore A transpose is A and B transpose is B. So transpose of this matrices is equal to that matrix. Therefore